Hello everybody and welcome back to MrMiers Math Channel. Today in Algebra 2AB we're going to talk about section 8.6, which is going to be solving basic exponential and logarithmic equations. Alright, so that's the goal. We've talked about all of our techniques with exponents and logarithms in the past, and now we're just building up to actually solving those exponential and logarithmic equations. And of course we're going to start pretty easy. So we're going to start with what's called the equal powers property. And this is something we might use when solving an exponential equation, and it basically is just generated from this question here. Okay, 3 to what power equals 3 to the 5th power? Now, in this question, obviously, if the bases of these exponents are the same, and we're trying to figure out what is the same as 3 to the 5th power, then it's obvious that we also have to raise this 3 to the 5th power. If we raise it to anything else, then these things aren't going to be equal. So that gives us x equals 5 as our solution. So that essentially yields us the equal powers property, which just says if b to the x power equals b to the y power, then x equals y. If they both have the same base, we got to be both raising them to the same exponents for them to be the same. All right, so if they have the same base, all right, then they have the same exponent. If they're equal, of course. All right, so moving on to example 1, solving the equation in part A, we have 4 squared equals 4 to the 9x minus 5. They have the same base, so if these quantities are equal, then obviously these exponents have to be the same. So all we got to do is just set the exponents equal to one another, and then just solve from there. And look how easy this is. All right, we can just add 5 to both sides, divide by 9, and we get x equals 7/9. Now that would take us maybe a little while if we were just doing guess and check and just plugging random values in for x. So using these exponent and logarithm rules is going to be really helpful for us so that we eliminate some of that time that it would take. All right, if we take a look at part B, notice this is 2 to the 3x power, and it's equal to 4 to the x plus 1 power. Now notice these bases aren't the same. So if the bases aren't the same, what we're going to do is try to make them be the same. Now we know that 4 is 2 to some power. Okay, 4 is 2 to the 2nd power. So instead of 4, we're going to put 2 squared right there. So we have 2 to the 3x equals 2 squared to the x plus 1. All right, and now we have to do some simplifying. Obviously, this would be using power rule in terms of our exponents. So we're going to multiply 2 times x plus 1, and we get 2x plus 2. We've got to distribute the 2 to both of these. And now we have the same base. So if we have the same base and these quantities are equal, the exponents have to be the same. So 3x has to equal 2x plus 2, and then we can solve from there. Subtract 2x on both sides, and we get x equals 2. All right, so using the equal powers property, this is rather simple. If the bases are the same, we just set the exponents equal to one another. If they're not, we got to make them be the same. So then we can use the equal powers property. All right, moving on. All right, now in this question, we have 3 to the x power equals 5. So essentially 3 to what power equals 5. Now we've dealt with this before. So what we're going to do to answer this question is we could actually do one of two things, and what I'm going to recommend is take a common logarithm of each side. So take a common logarithm of each side means write log, on both sides. So this becomes log of 3 to the x power equals log of 5. All right, so we're taking the logarithm of both sides, the common log of both sides. And then what we're going to do is use some of the properties that we know. All right, so we could rewrite this as x times log of 3 using our power property from the previous section. And now we can solve for x by dividing by log of 3. So we have log of 5 over log of 3. And if we round that to the nearest hundredth, we get about 1.46. All right, now moving on to the next one. For part B, once again, let's take the common log of each side and see what happens. So if we take common logarithm of the left side, we have log of 10 to the 2x plus 5 equals log of 6. Now, one thing that we should recognize is that this is the common logarithm, so it's got a base of 10. So notice that the base of the logarithm and the base of the exponent are the same, which just means that cancels out, and we just get 2x plus 1. Log of 10 base 10 is just 1. We know that to be true. All right, if we were asking ourselves, log base 10 of 10 is what? That's just saying 10 to what power equals 10, and we know that's just 1. Okay, 10 to the first power. So this is just 1 times 2x plus 5. So we have 2x plus 5 equals log of 6. Now from here we have to be rather careful. Okay, so we're going to subtract 5 first. So we have log of 6 minus 5. And then we're going to divide by 2. And we're going to divide that whole quantity by 2. And the reason why I said be careful is when typing this into the calculator, you got to make sure that you know what the calculator is saying. Okay? When you type in log, it's going to create a set of parentheses. Okay, those grouping symbols. It's going to create a set. All right, so you got to make sure that you terminate those grouping symbols right after you type in 6, because we're not trying to take log of 6 minus 5, or in other words, log of 1. We're trying to do log of 6 minus 5 all on 2. So also another thing, if we don't have a fraction button in the calculator, that means we need to use parentheses and division to type this all in, or do it in multiple steps. So if we were doing this all in one step, we would need to create another set of parentheses around this whole numerator and then divide by 2 in the denominator. All right, otherwise just do it in separate steps. You know, type in log of 6, enter, minus 5, enter, divided by 2, enter, and we get negative 2.11. All right, folks. Moving on to example 3. We have 10 to the negative x power minus 4 equals 13. So once again, we're ramping it up every single time. We can't start out by taking a common log of each side. That would not be recommended. So what we would want to do is isolate the exponent, essentially. So we'd add 4 to both sides. And then once we've added 4 to both sides, now we can take a common logarithm of each side, and this is going to be a lot simpler. So log of the left side would be log of 10 to the negative x. Log of the right side would be log of 17. Now this is our common logarithm, so they have the same base, and I'm just going to write it there so you can see that. All right, so log base 10 of 10 is just 1, and using our power property, that would put negative x over here. So it just cancels out, and we get negative x on the left side. So negative x equals log of 17, which just means x is negative log of 17. And if we type that in, round to the nearest hundredth, we get negative 1.23. All right, so we can use equal powers property. We could also use a common logarithm and take the common logarithm of both sides. Now we're going to transition into solving logarithmic equations. And of course, logarithms and exponents are inverses of one another, so these things are going to be rather similar. So equal logarithms property just says that log base b of x, if log base b of x equals log base b of y, then x equals y. All right, both logarithms have the same base, so obviously for these to be equal, the arguments have to be equal. All right, so using this equal logarithms property, in part A, log base 7 of 4x of the quantity 4x minus 3 equals log base 7 of the quantity x plus 6. All right, obviously, they got the same base, so these arguments have to be the same. So 4x minus 3 equals x plus 6, and we can just solve from there. Subtract x on both sides. Add 3. Divide by 3, and we get x equals 3. Awesome sauce. In part B, let's do the same thing. So they both have the same base, so we can set these arguments equal to one another. And then solve from here. Subtract x from both sides, add 5, we get x equals 7. Awesome sauce. Now, another thing that we could do, which we could have done actually in previous examples in our exponential equations, is we could exponentiate, or we could use the SWIRL method. We could rewrite this logarithm as an exponent, and vice versa from before. We could have rewritten some of those exponents as logarithms. So we're going to exponentiate, which means we're just going to write this as an exponent using that SWIRL method that we've talked about before. All right, so remember the SWIRL method? Starting at 2, going by 4, landing on 3x plus 1. And how we're writing that as an exponential equation is 2 to the 4th power equals 3x plus 1. Okay, now from here it's actually rather simple to solve. So 2 to the 4th power is the first thing that we would do. That's 16. 16 equals 3x plus 1. Subtract 1. We get 15 equals 3x. Divide by 3. And we get x equals 5. If we take a look at part B, let's swirl it again. Swirl it. 4 to the 2nd power equals 7x plus 2. 4 squared, 16. So we get 16 equals 7x plus 2. Subtract 2 on both sides. We have 14 equals 7x. And divide by 7. And we get x equals 2. Awesome. Not so bad. Now we're going to start utilizing essentially like all of our properties, all of the things that we know to solve some of these last equations here. All right, so in the next one, notice we have log of 10x plus log of the quantity x minus 3 equals 2. So in order to solve this, sometimes it's necessary to condense the expression first. Okay, because we can't outright just exponentiate right away. We can't do that because, okay, this isn't the only thing that we have in the equation. We've got another expression right here. Sorry. So one thing that we can do is condense this. They have the same base, so we could combine these two logarithmic expressions. And when we do that, that's using the product rule. Okay, so that's 10x times x minus 3. Multiply those arguments. And now from here, okay, we could combine these. We could actually go through and actually multiply these things. So 10x times x minus 3 is 10x squared minus 30x. Now remember, this is the argument of this logarithm, and so now we can exponentiate. All right, remember when we're doing this, keep in mind that that base is 10, so this is going to be 10 to the second power equals 10x squared minus 30x. Now 10 squared, of course, is 100. And notice we have a quadratic equation, so we want to get everything over to one side, so subtract 100. We'll get 10x squared minus 30x minus 100. Now we're going to try to solve this one by factoring. Of course, not all the time are we going to be able to solve this by factoring. So we're going to give it a shot here, and the first thing that we're going to look for is greatest common factor, which we do have. 10 is a common factor in each one of those terms. Oops. So we're factoring a 10 out, and what we got left over is x squared minus 3x minus 10. Now we want to factor that x squared minus 3x minus 10. That factors to be x minus 5 times x plus 2. Now we're going to set each factor equal to 0 and solve. All right, so obviously 10 can't equal 0. They're not the same. Okay, and then we'll set x minus 5 equal to 0. And we get 5. And then we'll set x plus 2 equal to 0. And we get negative 2. All right, we also have to check for extraneous solutions. There's some solutions that may not work in the context of this problem. So if we plug in 5 and we plug in negative 2, we'll figure out which one, maybe both of them work, maybe neither of them work, maybe one or the other work. So we would have, if we plug in 5, log of 50 plus log of 2, and if we do that, we get 2. If we plug in negative 2, we'd have log of negative 20 plus log of negative 5, and we're going to notice that that is the one that doesn't work in the context of this problem. All right, last example here. Okay, this is rather similar. Once again, we're going to condense this expression, and then after that, we're going to exponentiate. All right, so in condensing the expression, we're going to use product rule here. You see that plus sign. You see the bases are the same. We're going to take this, multiply it by that argument as well. I'm going to do that in all one fell swoop here. X plus 6 times x is going to give us x squared plus 6x. All right, just saving some room here. And then from this step, we're going to exponentiate. So use the SWIRL method. 4 squared equals x squared plus 6x. Of course, 4 squared is 16. I want to get everything over to one side, so subtract 16. We have 0 equals x squared plus 6x minus 16. And now we can try to factor. All right, this is factorable. We get 0 equals x plus 8 times x minus 2. And then set each one of these factors equal to 0 and solve. If we solve, we get negative 8 and positive 2. And let's double check those solutions. And negative 8 is the one that doesn't work. All right, 2 does work. All right, if we're wondering why negative 8 is the one that doesn't work, let's just take a look at this simple logarithmic expression. All right, so log base 4 of negative 8. What we're trying to do is figure out 4 to what power equals negative 8. And in this case, we can't change that positive number to a negative number with that exponent. Of course, we could take the square root of this, which would make it smaller. You know, we could take the cubed root and get an even smaller number. We could raise it to a negative power, but none of those things are going to result in a negative number there. So that's why negative 8 doesn't work in the context of this problem. All right, folks, if you have any questions, leave them in the comments. Send me an email if you have my email. If you enjoyed this, hit the like button. Subscribe, and thank you, and have a good day.